Metacognition is described as the ability to reflect on our mental representations in order to understand our cognitive processes and thus optimize learning. But what do we mean by reflection and metacognition within our model? We mean all those learning events that stimulate reasoning about the process that led to learning, so when and how it occurred, what the relationships are between the components of the system, what results it produced, and how it could be improved. Numerous studies highlight how encouraging reflection and metacognition means stimulating self-observation skills and the identification of better learning strategies. Activities that stimulate reflection and metacognition can be varied and are often paired with or follow other activities that promote awareness and reflection on the process. The teacher can, for example, ask students to create concept maps related to the overall learning process, organize reflection activities focused on the acquisition of transversal skills, shift the reflection toward connections with other subjects, or focus on identifying models that can be transferred to other contexts. Let's look at a few examples starting from the traditional context. After a series of lessons involving the collection of low interactivity content, the teacher can offer students an asynchronous online retrieval test that allows them to understand what has actually been learned and retained. Through automated systems, they could provide detailed feedback to help students understand how to fill in the gaps, supporting and optimizing the learning process. We've looked at a simple case, but reflection and metacognitive activities are all the more useful when learning events are varied and complex. When pausing to reflect on what is happening helps ensure that no essential elements are missed. For example, let's consider a course made up of several cycles. Within these cycles, on one hand, students attend some in-person classes where they gather highly interactive content. On the other hand, they supplement what they've learned through a portion of a MOOC, meaning they engage in collecting low interactivity content asynchronously. In the meantime, as part of the course flow, they carry out practical experiences in a virtual lab. How can we help bring all the different pieces together and optimize the learning process? At the end of a completed cycle, students could take part in synchronous online discussions in small groups, producing a short report on the main concepts, processes, and methods they have learned and experimented with, that is, on how and when the collected content supported the practical activity. This allows students to reflect on the process as a whole and to identify connections that, in the transition from theory to practice, might not be so obvious and could get somewhat lost. Attention! Reflection and metacognitive activities are also useful when learning outcomes go well beyond the acquisition and application of concepts and require the deployment of transversal skills and competencies. Let's take the previous example and imagine that each cycle ends with a production and research activity carried out in a group online, both synchronously and asynchronously. For example, by querying artificial intelligence systems to develop a small research project. Usually, this type of activity requires the application of both subject-specific and multidisciplinary knowledge. Not only that, it also requires the ability to work in a team, a good level of autonomy, problem-solving skills, and so on. The teacher could therefore ask the groups to reflect both on the connections between the various disciplines and on the process carried out as a group, as well as how individuals contributed to it. In this way, it encourages reflection both on the transdisciplinary knowledge and skills acquired and on the transversal abilities enhanced during the course. Putting all these reflections down on paper or visualizing them leads to greater awareness of the level of learning achieved and therefore of the steps needed to optimize it.